In this video, we're going to look at the learning target. I can solve systems of equations using linear combination with multiplication. So what you need to know. There are three methods to solving systems. Graphing, you can graph both lines to see where they meet. Remember that that point of intersection where the two lines cross is the solution or your answer to that system. There's also the method of substitution where you isolate your variable of either x or y and you plug that variable into the other equation to solve. And then lastly, what we're going to focus on today is elimination, where we line up variables, we look for matching coefficients, or today what we're going to focus on is multiplying to make them matching, and then we're going to add and subtract to eliminate. If you haven't watched the previous video on eliminating just using adding and subtracting, that might be a great place to start. All right, so let's take a look at this first example. We want to solve the system of equations. We have negative 3x plus 7y equals negative 16, and then our second equation is negative 9x plus 5y equals positive 16. So just like when we were eliminating systems of equations where we were already given everything kind of lined up for us, the x's would cancel or the y's would cancel from the beginning, we're going to start the same way. We want to make sure that our variables are lined up. And remember that when we're using elimination, we are using elimination because we're given two equations that are in standard form. That's your ax plus by equals c. So my x's are lined up, my y's are lined up. I want to look for the coefficients that are the same. So if I look at my x terms, I've got negative 3 and negative 9. Those are not the same. My y's, I've got a coefficient of 7 and 5. Those are also not the same. So when they're not the same, we have to multiply either one or both equations by a factor to make the coefficients equal. So what we can do here, if I look at my x terms, I've got negative 3 and negative 9. Well, I could make this 3 into a 9 by multiplying this entire equation by 3, right? Because 3 times 3 is 9. But since these were both negative and I want them to eliminate, I'm going to multiply it by a negative 3, so it turns this coefficient into a positive. I've got to distribute that negative 3 to all the terms inside of my equation, okay? So we're going to go ahead and do that. I'm going to rewrite that right here for step 2. So I'm going to have a positive 9x minus 21y, and then I have negative 3 times a negative 16, so that's going to turn into a positive 48. My bottom equation didn't change. I didn't have to because now my 9 x's are going to eliminate. When I add straight up and down 9x plus negative 9, that gives me 0x. Those are gone, okay? Negative 21y plus 5y is going to give me negative 16y. And then here we're just adding 48 plus 16 is going to give me 64. So now I need to get this y by itself. I've got negative 16 times y, so I'm going to divide, by that negative 16. So 64 divided by negative 16 is going to give me negative 4. Now, once you have solved for your variable, now is that last step where we have to substitute that answer into one of our equations to solve. So I'm going to go ahead and do this kind of up top here. I'm going to I always just pick my first equation. So I'm going to pick that guy and I'm going to take my value of y and I'm going to substitute that in. So negative 3x plus 7 times negative 4 equals negative 16. All right, so now I'm going to go ahead and simplify my next step. So negative 3x and then 7 times negative 4 is going to be negative 28 equals negative 16. Okay, so I want to get x by itself, so I'm going to have to move that negative 28 to the other side by adding. Remember, we use the inverse operation. So I'm going to have negative 3x equals, these cancel, and then negative 16 plus 28 is just 12. To get x by itself, we undo our multiplication by division, and x also equals -4. Check my answer there, -4, -4. So if you were to graph those two equations, that system, they would cross or intersect at the point -4, -4. All right, so in our next example, we're gonna, if you would like to try this one on your own, you can go ahead and pause right now, give it a try, and then come back and check your answer. So again, we want to make sure in step 1 that our x's and our y's are lined up. They are in the problems that were given to us. The x's and y's are already lined up. In the second step, we want to look for coefficients that are the same. So here, if you will look, we've got our x terms, the 5x and the 3x, those are not the same. My 4's and my -9 are not the same. So I'm going to have to do something to make them the same, and also so that they will eliminate. Now, I chose to eliminate my y's because one of my y's is positive and one of them is negative, and we always need that to happen. They need to be the same number. One needs to be positive, one needs to be negative, so that they will eliminate. So I chose my y's, and I just multiplied the top equation by 9 and the bottom equation by 4. You can always use this method when using elimination. If your coefficients aren't the same, you can just pick the coefficients that are given to you and multiply the opposite equation by that coefficient, and then they will always cancel. So once I do that, I had to distribute that 9 to everything inside and the 4 to everything in the second equation, and I end up with 45x plus 36y equals -270, and then 12x minus 36y equals -72. Notice now I've got my y's are the same, 36, 36, one is positive, one is negative, so they are going to eliminate. They cross out. So when I simplify, I am left with 57x because 45x plus 12x is 57, and then -270 plus -72 is -342. I now need to divide by 57 to solve for my variable. So my 57s will cancel, and I am left with x equals -6. Now we know that when we have that last step, we take that answer and we substitute it into one of our equations. Again, I picked the first equation and I just plug it in. So I plug in -6 for x. 5 times -6 is going to give me -30 when I simplify. And now I solve for y. So I have a -30. To undo that, we would add 30 to both sides. And I end up with 0 on the right because -30 plus 30 is also 0. So 4y equals 0. So y is just going to equal 0. So my answer for this system is at -6, 0. If you were to graph the system, you would see that that's the point of intersection. You could also check your work by plugging in your answer back into your equation to make sure that they're both true. As long as they're both true, you know you've solved the system correctly. If you need more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.